is 71st question. A mixture of potassium chloride, oxalic acid and sulfuric acid is heated. During the reaction, which element undergoes maximum change in oxidation number? So let us first write the equation for all. Okay, on heating we will get K2SO4 plus KCl plus carbon dioxide and water. So from this we know that hydrogen, oxygen and potassium is not going to change its oxidation state. So no change in oxidation state. Okay. Whereas if you take chlorine, there is a change of oxidation state, and carbon, there is a change of oxidation state. Okay. And in case of sulfur also we can check here. So if you take chlorine, what can be the oxidation state of chlorine here? It is plus 5. And what about here? Minus 1. So change from plus 5 to minus 1. And what about oxidation change here? Plus 3 state changes to plus 4 state. What about sulfur? Sulfur in both the cases we can find plus 6. And here also it is plus 6. So no change with the sulfur. So you can find a chlorine where number of electrons involved here is maximum, whereas here it is just only 1. So they are asking for maximum change in the oxidation number. So we can take chlorine as an answer. So option C is answer here. 72. The IUPAC name for the complex is, so it is given pentaamine, and nitrogen is connected here, and this is being a negative ligand, it should be nitrito N. Okay, then cobalt. What is the oxidation state of cobalt here? It is 3. When I take cobalt as X and put one NO2 group and its charge is minus 1, and here if you go and check the complex charge, you can find the complex charge to be plus 2. And 5 into ammonia being neutral ligand, it is 0, and that is equal to plus 2, and X equal to plus 3. So cobalt has plus 3 state. Can you find option D, which gives you pentaamine nitrito N cobalt 3 chloride, and that would be the right option. 73rd question. At 80 degrees Celsius, the vapor pressure of pure liquid A is 520 mmHg and that of pure liquid B is 1000 mmHg. If a mixture solution A and B boils at 80 degrees Celsius and 1 atm pressure, the amount of A in the mixture is, we have to find out the percentage, amount of A in percentage. Okay, so first we will go as per the Raoult's law. We know that P total vapor pressure is equal to partial pressure of A and partial pressure of B, and PA can be written as PA naught into mole fraction of XA plus PB naught into mole fraction of XB, and first we shall calculate the values of XA. Okay, so here I am going to convert XB in terms of XA. We know that XA plus XB is equal to 1, and hence XB is equal to 1 minus XA. So substitute them here, and XB now becomes 1 minus XA, and this is equal to, from PT is equal to PA naught XA plus PB naught minus PB naught XA. We can find the values of PT here, which is nothing but 1 atm. So all are in mmHg. So I am considering 760 mmHg. So 760, and that is equal to PA naught value here, pure solvent value is 520 mmHg into XA plus, what about PB naught? It is 1000 mmg and minus, and here comes mmgHg. What about XA? We need to find. So solving this, you can find XA to be 0.5. They are asking percentage amount of A, and answer is given in mole percent. So I have to multiply that 0.5 into 100, which gives you 50%. Okay, so here the correct option is 50. Option C. 74. Reaction of carbonyl compound with one of the following reagent involves nucleophilic addition followed by elimination of water. The reagent is, if you take a Grignard reagent RMgX, which also go for nucleophilic addition, but elimination of water is not carried out in this reaction. Whereas if you take a hydrazine, I am taking hydrazine NH2 NH2. Okay, now I am going to do nucleophilic addition by dissociating this one into NH minus and H plus. So H plus goes here, okay, and minus will go to carbon. As a result, we have NH2N NHC OH here. Okay, after that you can find the elimination of hydrogen and OH as water here, that leads to N double bond C. So the correct option is B, where hydrogen in presence of feebly acidic solution will have both nucleophilic addition as well as elimination of water. Whereas if you go for hydrocyanic acid, nucleophilic addition of course will be carried out, but elimination of water is not proceeded. Whereas in case of sodium hydrogen sulfate, there is a possibility of nucleophilic addition here also, but that should be with the addition of HCl that leads to water. But by himself it is not giving water out, as in case of option B. 75. The hydrolysis constant of 0.5 m ammonium benzoate is 6.25 to 10 to the power minus 6, the percentage hydrolysis of the salt. We know the formula that H is equal to square root of KH divided by C, and I can substitute this hydrolysis constant KH from the question, which is 6.25 into 10 to the power minus 6, and what about the concentration? It is 0.5. So okay, when we solve this, we have the value 12 into 10 power minus 6. So H is equal to 12 into 10 power minus 6. When you take a root of, we know that 9 is the square number of 3, root 9, and root 16 is for 4. If it is root 12, it should be between the values of 3 and 4. Okay, so I am taking approximately 3 between the value 3 and 4. So it can be 3 point something into 10 power 6 by 2. 10 power divided by 2 will give you minus 3. Here H is equal to, okay, 0.003. They are asking for percentage hydrolysis. So I have to multiply this one with 100, which gives you 0.3. So here the one and only value you have around 0.3 is option A, 0.35. 76th question. So here Cu plus gain of electron gives you Cu whose electrode potential is taken as x1, and for Cu2 plus, here 2 electron is added and gives you Cu. Here the reduction potential is taken as x2. Okay, so we need to have this overall equation. How can we get? We should have Cu plus on the product side. So I have to reverse this first equation as Cu plus 1 electron out, and hence the reduction potential get reversed, giving you minus sign. So E naught is equal to minus x1. And what about Cu2 plus 2 electrons here? It is Cu, and here the electrode potential is of course x2. So when you take delta G or total electrode potential, the number of electrons also plays a vital role. So I can take 2 electrons involved here as 2x2. So I am now getting the total overall cell reaction as Cu2 plus, adding these two, Cu2 plus 1 electron gives you Cu plus, and they are asking E naught for this one. When I add these two, it is very clear, it is 2x2 minus x1. So E naught could be the value 2x2 minus x1, option D. 77. Which of the following pair represents linkage isomerism? So when you find the first option, okay, you can form 2 linkage here. One central metal with nitrogen and another central metal with sulfur. Okay, so you can find the linkage isomerism is with the ambidentate ligand. Ambidentate ligand, so option A could be the correct one. Where the remaining ligands, if you check, there is no ambidentate ligand that leads to linkage isomers. 78th question, which of the following has the highest pH? So if you check here, we can find the highest pH can be given for base, that is basic natured salt here. If you check all the three options, you can find here strong acid, that is HCl plus weak base NH4OH. So this is going to be acidic salt and has the pH less than the remaining. And what about here? We have a weak acid plus a strong base. Okay, and here also we will check with that. Here we have Na with the strong base plus HNO3. Okay, HNO3, that is strong acid. NaOH plus HNO3. And what about option B? We have NaOH plus H2CO3, carbonic acid, which is actually the weakest acid in inorganic acids. So NaOH being a strong base. So we can have these two options A and B in confusions. However, the basic nature when you compare, which will be little greater for NaOH leading to higher basic nature compared to A option, and hence B can have the highest pH. So the correct option would be 78B. 79. Arrange the following amines in the decreasing order of basicity. So can you find lone pairs present in your nitrogen? If you take a structure 2, okay, structure 2, this pair of lone electrons are involving in resonance. So this nitrogens will not tend to give lone pairs very easily. Okay, and what about here? In these two cases, if this nitrogen is donating electrons, the tendency is very least because it will get a positive charge, okay, and the resonance get disturbed. So this nitrogen tendency is also somehow less. But if you go for here, this structure, third structure, where nitrogen has a lone pair which immediately donates. So we know the base is a substance which immediately donates electrons, and it is structure 3 which immediately donates electron. Okay, and we have C and B option. And next to third structure 1, and the least will be where the lone pair involved in resonance, which this nitrogen will not give out, is least here. So option B would be right. 80. The density of 2.05 molarity solution of acetic acid in water is 1.02 gram per ml. The molality of the solution is, we already know we have a direct relation of finding this molality and molarity. That is small m is equal to capital M into 1000 divided by rho density into 1000 minus capital M molarity into molecular weight of solute. Here what is the solute? Acetic acid. Now let us calculate the molecular weight of acetic acid, which gives you around 60 gram, right? And we will substitute all the values now. What is the molarity? 2.05 into 1000 whole divided by 1.02 into 1000 minus, what is molarity here? It is 2.05 and molecular weight is 60. When you solve this, you will get the molality around 2.28, which is option B. Question number 81. The tendency of BF3, BCl3 and BBr3 to behave as a Lewis acid decrease in the sequence. First, let us draw the structure of BF3, BCl. All of course have sp3, sp2 hybridization with trigonal planar. But if you check the side atoms, surrounding atoms are different. Where fluorine all have 3 lone pairs of electrons. All have, of course, 3 lone pairs of electrons around them. But if you check the closeness or the proximity of these lone pair electrons, okay, when the size increases, these lone pairs move away from each other. So as a result, we can conclude Lewis acid is an acid which accepts electron, isn't it? So what is Lewis acid? Those which accepts electron will be the strong Lewis acid, accepts electron. Here fluorine which feels lone pair repulsion to a greater extent because of the smaller size, okay, will make this boron to be less available to gain electrons. Whereas when you go for chlorine, it is little bit lower. Whereas if you go for bromine, where the lone pair repulsion is least, makes your boron to gain electron. Okay, so compared to BF3, it is Br3 which acts as a good Lewis acid because it accepts electron very immediately compared to other two. Okay, so I can take option B, where Br3 is greater than BCl3 than BF3 because of this lone pair effect. 82nd question, which compound out of the following is not aromatic? So if you check all the 4 options, children, you have here 2 pi electrons. Okay, here 4 pi electrons with the conjugation. Here also with the conjugations, you have to include this minus also. So totally 2, 2, 2, and here also 2. You have 8 pi electron. And in this case, there is no conjugations. No conjugation. However, you have 6 pi electron. And we know what are the conditions for a compound or ion to be aromatic. They should obey Huckel rule. They should obey Huckel rule, and there should be planarity, and it should be cyclic, and you have conjugation of double bond and single bond. If all the 4 conditions present, we can consider them as aromatic. However, here they are asking for not aromatic. So not aromatic na, see 2 pi electron is actually aromatic, which obeys Huckel's law and have planarity, cyclic and conjugation. So I cannot take A option. But if you go for B option, this is actually 4 pi electrons. If it is Huckel rule, it should have a 2 pi electron, then 6 pi electron, then 10 pi electron, and go on. If it has a 4 pi electron, then this would not be aromatic in nature, so I can take B. And if it has a 8 pi electron, that is also not aromatic, even though it has a conjugation and cyclic nature. And if you go for D, there is no conjugation at all. So all these 3, B, C, D, can be taken as a not aromatic. So the correct option would be B. 83rd question, how many alkenes which on hydrogenation gives you 2-methyl-butane? First, let us write the structure of 2-methyl-butane. Okay, 2-methyl-butane. CH3, CH3, here CH2. Second carbon will have 1 methyl group. So here 1 hydrogen should present. So what are the possible way of bringing this compound? They can have either double bond in this carbon. If you go for hydrogenation, it will give you, if you go for hydrogenation, the addition of H2 will make this 2-methyl-butane formation. And second case is CH3C. You can have a double bond between, okay, second carbon and the third carbon, where on hydrogenation, addition of hydrogen gives you the above compound. And what is the third possibility? Third possibility is CH3CH2CH. Okay, and in this case, both are on same atmosphere. So they are very equivalent to each other. So if you give double bond to 1 carbon, that is enough. Okay, I am removing this. Second carbon and the first carbon hydrogen. Now, if you do hydrogenation, again it will give you 2-methyl-butane. So here 3 possible alkenes can be taken that gives you 2-methyl-butane on hydrogenation. So the correct option here, it would be 3. 84th question, a reaction having equal energies of activation of forward and reverse reaction has. So from chemical kinetics, we know that delta H is equal to energy of activation of forward minus energy of activation of backward can be taken. Here both are equal, or both are equal energies here. Then I can take 0. So delta H will be 0. So option B will be right. 85th question, which of the following is a pentose sugar? So glucose, this is actually glucose. So glucose and fructose both are with the 6 carbon compound, and it is ribose which has 5 carbon that gives you pentose sugar. So the right option is option A, in which can change in entropy is negative. So look at this equation. So 2 atomic hydrogen now becomes molecular hydrogens. So even though both are gaseous forms, okay, the number of hydrogen availability is decreasing from reactant to product side. and hence the randomness of your atoms will decrease here. So here I can expect delta S could be negative because randomness entropy is nothing but disorderly. So that will reduce in the first case. Evaporation of water, of course, liquid to gas, you can find entropy increases, and expansion of gas also where volume is higher and you can find the movement of your gases increases. And sublimation of solid to gas, of course, your entropy, randomness, disorderliness will increase, and hence the correct option would be A. 87th question, ionization constant of CH3COOH is 1.7 into 10 power minus 5 and concentration of H plus is 3.4 into 10 to the power minus 4. Then find out the initial concentration of CH3COOH. First, let us go for the dissociation of this weak acidic acid that gives you CH3COO minus plus H plus. If I consider the initial concentration of acetic acid to be C and these two ions are 0, 0 at equilibrium, I can find some amount of acetic acid get dissociated giving you X acetate ion and X H plus ion. If I take a ionization constant, okay, equilibrium constant Ka here, that gives you concentration of product divided by concentration of reactant. Concentration of product here is constant CH3COO minus, which is X, and concentration of H plus here is X. So concentration of product divided by concentration of reactants. And what is reactant here? Which is nothing but acetic acid and has the concentration C minus X. Being a partial dissociation whose concentration for weak acid is negligible, I can simply take X into X by C. So I can substitute the value of X here, which is the concentration of H plus ion given 3.4 into 10 to the power minus 4 into 3.4 into 10 to the power minus 4 whole divided by concentration, okay, of your, this one is initial concentration. Let us keep this as C because the question is initial concentration of acetic acid, and Ka is given, which can be substituted as 1.7 into 10 power minus 5, and hence C is 3.4 into 10 to the power minus 4 into 3.4 into 10 to the power minus 4 whole divided by 1.7 into 10 to the power minus 5. When you solve this, you will have the answer. 6.8. So if you go for this, you will have minus 1. So when you go up, it gives you 10 to the power minus 3. 10 to the power minus 3, and hence the correct option would be option D. 88th question, red hot carbon will remove oxygen from the oxide AO and BO but not from MO. Okay, while B will remove oxygen from AO. So it is given that, okay, carbon with MO, there is no reaction. Why? Because it is given, it is not, your carbon cannot take oxygen from MO, and that shows that M is more reactive. M is more reactive compared to AO and BO. And what is the next clue? When B reacts with, and it will remove oxygen from AO. So B reacts with AO now, it removes O from A and giving you A. And this shows that B is more reactive than A. So based on these two, we can arrange them as M has more reactive nature than B than your A. And hence the right option is C. 88, option C. 89th question, if the rate constant for the first order reaction is K, the time T required for the completion of 99% of the reaction is given by. We know for the first order reaction, K is equal to 2.303 by T into logarithm of initial concentration by final concentration. So here the final concentration is 99. I can take initial concentration as 100% and here 100 minus 99%. As a result, I can write K is equal to 2.303 by T log 100 by 1 gives you 100, which can be rewrite as 10 power 2, and this 2 can be brought in front. So 2 into 2.303 by T log 10 becomes 1. Log 10 is equal to 1. Therefore, I can rewrite as 4.606 T into 1. They are asking if the rate constant is K, the time required. So I can write T T is equal to 4.606 by K. The correct option here, it would be D option. 98th question, which one of the following compound is most acidic? And we know that when minus I effect increases, acidic nature also increases. So among the four options, you can find due to the formation of phenoxide compared to aliphatic alcohols, okay, aromatic alcohols will have more acidic nature because of phenoxide formation. So among B, D and C, if you find here NO2 which is very closer to OH will have a minus I effect and this will have a plus I effect, and here we have a hydrogen. So ordering them, it is very clear that it is B which has more acidic than your C than your D. So they are asking for more acidic, it should be option B with the NO2 group.